Hi, it's Robin. In a previous video, we looked at one of my favorite original Commodore 64 games, LeMans, from about 1982, made by HAL Laboratories. As much as I love the game, there was always a nagging feeling that there was something kind of wrong with the game, whether it was a bug, or maybe the game even cheated a little. So I wanted to look into it, but I wasn't able to use my Super Snapshot to examine the contents of a cartridge. They weren't compatible with each other. So I spent much of that last video figuring out how to dump that cartridge onto disk or SD card for storage, so I could then use the code inspector to examine the actual code. And I'd actually wanted to know how to dump a cartridge for a long time. It's one of those things I'd kind of put off learning how to do, especially an Ultimax cartridge, which this is. So that's what we did in the previous video, along with some gameplay and so on. So if you haven't seen the previous one, you might want to watch it. There'll be a link in the video description. While I was able to successfully dump the cartridge, actually starting the game was a bit of a chore, with a few instructions in the monitor required. I think what we should do first is make that cartridge dump runnable as a regular Commodore 64 program. That's kind of a useful thing in its own right. If we happen to crash the game or have to restart it, it'll be a lot easier to just be able to load and run our dump again instead of having to go through those various incantations to start it each time. Okay, so I've loaded up Turbo Macro Pro from disk. There'll be a D64 to download in the video description if you wanted to follow along. And once the program's been loaded with COM8, then sys 32768 to start it. So to load the source code, back arrow L, and the latest source code is called SRC6. If I notice any bugs, then I'll update it with a newer version. Okay, so we're going to go through this fairly short assembly language program that allows us to take that cartridge dump we made last time and make it runnable. So let's just go through it here. I've got some labels. CRT source stands for the cartridge source location, not source code, but the source memory location, and we're going to load it at 900 hex, and I've just chosen that because it's an even page value that comes after 0801, which is where our executable code will be, and this is where all Commodore 64 programs, well, not all, but all runnable basic programs usually load to 0801. We'll look at that more in just a moment. Now, while the cartridge dump is going to first load into memory at location 900, it actually has to be moved all the way up to E000 or E1000, I like to say. This is where it needs to go in memory, and we're going to copy it up there in a moment. And then, as discussed last time, this Max Machine cartridge actually has its graphics data up at F1000 hex. That's part of the Max Machine specification. The VIC-2 graphic chip sees graphics way up at that location in cartridge ROM. And when a Commodore 64 is in Max Machine mode, it duplicates or emulates that functionality. But we're not using the cartridge with those pins grounded as we showed last video. We're running it in native Commodore 64 mode, and that's not accessible through software, only through hardware. So, long story short, we need to copy the graphics from F1000 hex down to 3000 hex. And so I've just defined those labels so they're easy to change in case something in the future requires different addresses. Okay, now we're telling Turbo Macro Pro where to start assembling, and as I said, executable Commodore 64 programs generally start at 0801 if they're runnable. And then these next lines I've examined in other videos, but to go over them quickly, this is what we sometimes call a basic stub or header that essentially simulates or duplicates the bytes needed to have a short basic program. So we're just replicating what the basic interpreter does when you type a program in, but instead we're doing it in hex bytes here in the assembler. So it's just all one tidy piece of code. So the first is a word byte that points to 080B, And that is just going to point ahead to these 0 bytes at the end of the program. Every Commodore BASIC program has to start with a 16-bit pointer to the second line. If it's just a one-line program, it points to these zeros that indicate the end of the program. The next 16-bit word is the line number of your program, and it's tradition, whatever the current year is, that is the line number. You don't have to do that, but it's just a way of making use of those bytes. Anyway, this is the year of release. Next is 9E. This is the basic token for the sys command. When you type sys into a basic program, it gets crunched into this single byte token 9E, and it represents sys. And then following that are PETSCII representations of the address that you want to sys, that is, call a machine language routine. This is where it exists in memory. And these are actually the bytes for 2061. This is the hex representation of this string, 2061. And it's easy to read that if you know this trick, that the first hex byte will be 3, and then the second one will be the actual number. So that's 2, 0, 6, and 1. And that matches right here. And 2061 is the address where this first actual assembly instruction is going to assemble to. And we've just worked that out by counting here. 0801, 2, 3, 4, those are 2 bytes each, 5, 6, 7, 8, 9, and 10, 11, and 12. 12 decimal, plus this 801 hex is 2049 decimal, add 12, and you get 2061, which is going to be this instruction here. And then finally a 0 byte to end that first line, and then 2 more 0 bytes to indicate the end of the program. That's just this pointer here pointed to 0, which indicates the end of the program. Okay, that's the basic header stub. Now our actual program. We're going to set the interrupt disable because we're going to be switching out the kernel ROM, so we want interrupts to be stopped. Then we're going to store value 35 hex in location 1. What that does is disables the kernel and basic ROMs and reveals the RAM underneath, which is where we want to copy the cartridge to. Next, we're going to set up to call a copy routine that we've written, and we'll look at shortly. And we're going to load the high byte of the cartridge source location into the accumulator. The cartridge destination high byte, that's what this symbol means here, of a 16-bit address. This symbol means take the greater, the high byte, and load it into the Y register. And then we want to copy 32 pages, and we put that in the X register. 32, because the cartridge is 8K, is the same. Each page is 256 bytes. And if we multiply that by 32 pages, 256 bytes equals 8,192 bytes, or 8 kilobytes. Okay, and then we're going to jump to the copy routine. And we'll look at that in a moment. And then likewise, we're just going to reuse this copy routine. But this time we're going to copy the graphics source from F1000 hex down to the destination of 3000 hex. That's those defines we did up above here. And this time we're going to copy 16 pages, or 4K worth. That's the upper half of the cartridge. And again, we're going to do the copy. And I just put this to do patches, just in case you want to add some modifications to the game. This is a great place to do it. We're not really going to be doing that, I don't think, but that's where it could be done. You do all the copying, and then the final thing is to just jump to E037, which is the start code of that game. And we looked in the previous video, we figured that out, E037. That was in the reset vector at the end of the cartridge ROM at what, FFFC, I think, and D, 16-bit pointer. But it's this middle one that whenever the 6502 resets, then it starts executing code at this location, which on this cartridge is E037. So that's our address, E037. Let's see what happens. And the final thing is just this little copy routine. Note that this copy routine only handles page-aligned copies, meaning that copies full pages starting at the beginning of each page that is an address ending with 00 hex. If you don't like that, then you can rewrite it. I just did it because it was tidier for this section here. We only have 3 registers anyway. We're going to put the source high byte in location FC and the destination high byte in FE. And we're going to load Y with 0 and store in the low byte of FB and FD. And this way Y is already initialized and our 16-bit pointers are set up. So we're going to load from FB using indirect indexing, and we'll copy it from the source location to the destination location indexed by Y. So it's copying a single byte, the first byte, and we increment Y, and while it's not equal to 0, we loop, and that will copy the whole first page in a fairly tight loop. 256 bytes are now copied, and Y conveniently goes back to 0. It loops around, so we don't have to reset it. And then we can just increment the high byte of both the source and destination, decrement X, which we set as the number of pages we want to copy. And if that's not equal to 0, then we just loop up and do it again. So that will quite rapidly and efficiently do the copy that we want to do, and then just return. Okay. So we can assemble that with back arrow 3, but we are not going to start the program yet. We want to do 2 things here. So I'm going to use my Super Snapshot monitor, pop into the monitor. So what we're going to do is I'm going to load the LeMans file. That's the actual dump that we did last video. And we're going to load it from device 8. But instead of loading it to, say, E1000 hex or wherever else, I'm going to load it to 900 hex. That's just the first page after our program that's at 0801. If you're really worried about wasting those 200 and whatever bytes, that could be improved in the code, but anyway, I think this is good enough. Okay, so just going to load in that cartridge dump, and it shows the normal address is E000 hex. That's where that dump normally should go, but instead, we're going to load it to 900 hex. Okay, and because it is 2000 hex bytes long, it shows the actual ending address of 2900. Okay, and now what we can do is save, I don't know what to call it, run LeMans from 8, and we're going to save it from 0801. This is actually creating that final executable file all the way to the load address. So this is device 8, 0801 is that same address we assembled our little program to with that RUNnable basic stub I explained, and to the end address, just matching this address right here. So this is saving both our assembled code plus the cartridge dump as one more or less contiguous block. Just seems a bit cleaner this way to me. Okay, here we go. We're going to save it. Okay, it's done. I'm going to just reset the computer. And now we can load run LeMans, comma 8. Oh, I didn't change the cursor color. Okay, now we can list our program. And you'll see this is the end result of that little basic stub we made. And that means that we can now run it and hopefully it will appear, our game. And there it is. All right, just make sure it works okay. There we go. Oh. Okay, all that to make the game runnable. Hopefully you find that useful for something else. But that general idea can be applied to all sorts of programs. Hi, it's Robin from the future, where I still say LeMans, even though I know I should be saying LeMans. Anyway, I had a few people point out that there's a typo in the game that I somehow never noticed. I guess I was too busy actually playing the game. I've got my original LeMans cartridge plugged in, just so you can see that this bug or typo is in the original game. That's not a result of my dump. So you know that as you play this game, as you pass the cars, they add up in the bottom right corner there, little purple icons. And watch, oh! Now I gotta start over. Once you pass 10 cars, you get 1,000 bonus points, and a little message appears. And look for it, here it comes. Oh, well, there, BOUNS, 1,000 points. So it's, I think, obviously supposed to say bonus, not BOUNS, unless that's French. Should I say BOUN? Well, that wasn't a very good game. So yeah, it only appears for just a moment. I guess my eyes were always on the road where they should be, so maybe that's why I never saw it, although I don't know why I didn't see it during editing. But anyway, BOUNS. So in the second part of the video, I want to see if we can fix that. It's not very difficult. I think we can do it. So I'll take out my LeMans cartridge. I'll use my Kung Fu Flash that I've got programmed with the latest Snappy ROM from Adrian Gonzalez. Okay, so I'm just going to type in BOUNS at the top of the screen. That'll come in handy in a moment. And if I press F8, we'll go into the Super Snapshot Monitor. Okay, so first we should load the cartridge dump into memory. Load. And I've just called that file LeMans. That's what we dumped in the first video in this series. Now let's load it to location E000. And now it's there in memory, but it's being loaded under the kernel ROM where Ultimax cartridges go. The original Max machine didn't actually have any ROM built into the machine at all, so the cartridge sat at the top of memory to populate the CPU vectors up at FFFA to FFFF. But here on the C64, we need to switch the ROMs out. And that's easy to do. Just display memory location 1. And this is the input-output port that controls the memory mapping on the 64. It's currently 3.7 hex. If we change that to 3.5, that will turn off the bits, revealing the RAM under the kernel. So now if we look at memory at location E000 or E1000, that's not the C64 kernel anymore. Instead, that's the cartridge dump. Okay, so the next thing to do is to find that misspelled word in memory. And we hope that's encoded in plain text. We can just hunt from E000 to FFFF and then put a quotation mark and just type in, oh, I almost spelled it right, BOUNS. But it didn't find anything. That's okay. If we shift to lowercase, we can just type it in caps. Oh, I did it again. BOUNS. Just in case it's encoded that way. Probably not. Nope. Okay, so we should probably search for the hex bytes directly. It may be encoded as screen codes. Now, how do you find out the screen codes? Well, for sure, B is 2, but then rather than figuring out the OUNS, which of course we could do, when I typed in BOUNS on the screen before I went into the monitor, that's stored at the top of screen memory 0400, and there it is. BOUNS shows up at the right here, and there's the hex bytes for it. So just a little shortcut there. So now we can hunt through memory, and hopefully that sequence of bytes will be there. OF 15, I guess we don't even have to do all of them, but I might as well. And there it is, at location F443, BOUNS. So there's the actual text misspelled in the dumped ROM. So I suppose we could just swap them here, OE and 15, and I just press return. Unfortunately, it doesn't update that right side automatically. That's a shortcoming of Super Snapshot. Doesn't have many, but that's one. But we just display it again. You can see it's spelled correctly. You can see a couple other messages there. Points and extended time. Okay, so if you'd like, you could just save the dump out at this point. You know, like fix dump from 8, like that. Although it doesn't save that last byte, which is kind of a flaw here. We talked about that in the previous video. This last value here is non-inclusive, and unfortunately 000, which may be a workaround, doesn't seem to work on the Super Snapshot. I'd love it if Adrian fixed these, or maybe I can help him fix some of these things, maybe in the future. But there are reasons you might want to keep the original dump, matching the cartridge, and do the fixes in our little program we created in the first half of this video. So if we just remember here that F445 is the NU right here. 0E goes in F445, and 15 hex goes in F446. Okay, so we'll just reset the computer here. Now I'm going to load up Turbo Macro Pro. That's the same as loading it with .8, .1, using that percentage sign as just a wedge, a convenience wedge that many cartridges have. Sys 32768 to start it up. Oh, that's a bit corrupted memory. Just back arrow C to cold start and Y for yes. That's interesting that that was something I was doing earlier, and it's still in there. It survived a couple cartridge swaps too. Okay, so we've done a cold start here. Now we can load up source 6. And this is all there is to it. And I mentioned before, just in case we want to do any patches, this is a perfect place for them. This way we can leave the original cartridge dump alone. And since we're already doing all these, the copying around in memory and all that, might as well do the patches right here too. So at this point, the copying's being done. Everything's where it needs to be in memory. And right here, we can patch those memory locations. So all we have to do is load A with E, that's the letter N, and store it in F445. And then load A with 15 hex and store that in F446. That's putting the letter U in the correct place. So we've just swapped those two letters. Some of you might philosophically prefer actually loading in the letter from F446 and then swapping them without actually having them hard-coded here. I don't know. You can do that if you want. Okay, so we're going to try this. Back arrow 3 to assemble into memory at 0801. But instead of starting, back arrow 1 to escape to basic. We'll freeze the computer here and press M to get into the Super Snapshot monitor. And just to be sure, we're going to load in the LeMans dump again from device 8. And again, this time to location 900. And now we're going to save that as fixed. Device 8 from 0801 to 2900. And we will reset the computer once again. And now let's just try loading up. Fixed, (8). There it is. We'll list it. There's our sys code. Oh, I should change that to 2024. Oh well, too late now. And finally, run. There it is. Everything looks good. And let's play it and see if we now have BOUNS instead of BOUNS. 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 1, 2, 3. Let's get to 10. 4, 5, 6. Ooh. 7, 8, 9. Here we go. BOUNS! It worked. Oh. Yeah, the collision detection's being like generous to me today. Well, there. I spoke too soon. Can I get extended play? There we go. Oh. BOUNS. Okay. Back to Robin of the past. Okay, that's it. I hope you enjoyed this video. If you did, consider giving it a like and subscribing to the channel for more of my videos. Thank you very much to my patrons for their support. Thank you for watching, and we'll talk to you next time.